Welcome to daily practice. In this video, I am going to explain you how to approach the question that you can see on your screen. So do watch this video carefully till end so that you will get complete idea to approach such kind of question. So let's begin the solution of this question. On the screen, you can see that this is the function of x that we have to differentiate. This is the function of x we have to differentiate. Now, as this is inverse function, we first convert this function of x into function of y. Then we differentiate this function of y, which is equal to x. Now, once we get the value of dx by dy, by using the theorem to differentiate inverse function, we get dy by dx, which is equal to 1 upon dx by dy. So let's start the solution of this question. So first step is we will assume this given function as y is equal to cos inverse of sine of 4 raised to x. Now here you can see that we have cos inverse and here you have sine inverse. So what is the direct relation between sine and cos is sine theta is equal to cos pi by 2 minus theta, and cos theta is equal to sine pi by 2 minus theta. So in this way they are related to each other. So what we can do here is we can convert this function, that is sine theta. We can convert this function of sine into cos using this relation. So let's do that. Cos inverse of. Now how to do this? Let me show you. Now this sine I will write it as cos. Then this pi by 2 as it is, and minus theta. Value of theta is 4 raised to x. So in this way we have converted the given sine function into cos. Now we know that this cos inverse and cos will get cancelled. So this y will become pi by 2 minus 4 raised to x. This is function of x. Now I will convert this into function of y. So 4 raised to x is pi by 2 minus y. If I take a log on both the sides, then what I will get? Log of 4 raised to x is equal to log of pi by 2 minus y. X is x into log of 4 is equal to log of pi by 2 minus y. Then this equation becomes x is equal to log of pi by 2 minus y divided by log of 4. So this is the function y. Now we will differentiate this function of y. Then what we will get? Dx by dy is equal to this 1 upon log 4 will be common. So 1 upon log 4 is constant. So I will take it outside. Then I will differentiate this log of pi by 2 minus y. So derivative of log of pi by 2 minus y is 1 upon pi by 2 minus y multiplied by derivative of this pi by 2 minus y. That is derivative of pi by 2 is 0 and derivative of minus y is minus 1. Now on differentiating this, what I will get? Minus 1 upon log of 4 into pi by 2 minus y. Now what I will do? I will put the value of y from equation number 1. So what I will get? From equation 1, dx by dy will be equal to 1 upon minus 1 upon log of 4 into pi by 2 minus pi by 2 minus 4 raised to x, minus of minus pi by 2 minus 4 raised to x, that is equal to minus 1 upon log of 4 into pi by 2 minus pi by 2. This minus minus will become plus, and this 4 upon x as it is. Pi by 2 will get cancelled. So what will be remaining? Dx by dy is equal to minus 1 upon 4 raised to x into log of 4. Now once we get the value of dx by dy, we will use theorem of derivatives of inverse function. Dy by dx is equal to 1 upon dx by dy. So the value of 1 upon dx by dy is 1 upon minus 1 upon 4 raised to x into log of 4. Therefore, dy by dx will be equal to minus 4 raised to x into log of 4. So in this way, we have obtained the required answer using theorem of derivatives of inverse function. Now, I will show you how to use the direct approach to solve this question. This direct approach method uses the uh, derivative of composite function, obtain the derivative of required function. So how this will be used, let's see. Suppose this is given function, cos inverse of sine of 4 raised to x. Now what will happen is this sine 4x will be taken as f of x, sine of 4 raised to x, and derivative of it will be derivative of sine will be cos of 4 raised to x multiplied by derivative of 4 raised to x, that is 4 raised to x into log of 4. Then when we put this function as f of x, then this y becomes y is equal to cos inverse of f of x. Then derivative of this cos inverse is minus 1 upon under root of 1 minus f of x bracket square, which will be multiplied with derivative of f of x, that is f dash of x. Now what I will do, I will put values of this function over here. Then what I will get, minus 4 raised to x into log 4 into cos of 4x divided by under root of 1 minus f of x is sine of 4 raised to x bracket square is equal to 4 raised to x. Now this minus 4 raised to x into log of 4 will be multiplied with cos of 4 raised to x divided by this 1 minus sine of 4 raised to x bracket square under root of will be written as under root of 1 minus sine square 4 raised to x. On further solving this, minus 4 raised to x into log of 4 into cos of 4 raised to x will be divided by this 1 minus sine square will become cos square 4 raised to x, and this cos square 4 raised to x will be written under root. So after taking cos 4 raised to x bracket square outside the root, then what will be left with? Then what we will be left with? Cos of 4 raised to x. This cos of 4 raised to x and this cos of 4 raised to x will get cancelled. So the final value of dy by dx will be equal to minus 4 raised to x into log of 4. So this is the required answer of this given question. So I hope you have understood both the approaches that I have taught you in this video. So if you have understood, give this video a thumbs up and share it with your friends, and don't forget to subscribe our channel for more such content. See you in the next video. Till then, keep practicing.